My screen's not moving. There we go. Okay, 2019, question 6. I'm trying to get that to stop. I can't get it to stop. I'm having computer problems. There, now I'm not. Okay, we've got all this information. It starts off with, write a third degree Taylor polynomial for f about x equals 0. So what do we know about f? A portion of the graph of f is shown above. So, along with the line tangent to f at x equals 0. And the tangent line is actually going to give you the first two terms of your Taylor formula. So let's get the equation of that line. We're dealing with a centered at 0. So that means I am using the point 0, 3. And I have a slope of -2. So if I write the equation of that line, and actually that's my y-intercept, so let's just do mx plus b. But we want to write that in the opposite order, and that begins our Taylor polynomial. So I've got 3 minus 2x, and now I need to find the term for the second degree. And I have that selected derivatives of f at x equals 0 are given in the table above. When n is equal to 2, I get that the second derivative value is 3. So let me remind you, the Taylor formula is nth derivative at the center over n factorial, x minus the center to the n power. We are trying to find the x squared term, so I'm plugging a 2 in for all the n's. I just found that the second derivative at 0 is 3. The chart told me 3. And then all the n's are 2's. Then I need to move on to n equals 3. And let me emphasize that that n is also 3. I need the third derivative at 0. Third derivative at 0 is -23/2. What a lovely number. And then over 3 factorial times x cubed. So this is my third degree polynomial for f about x equals 0. And I'm putting squiggly equals because I ended it at degree 3, didn't go to the infinity formula. All right, B, write the first 3 non-zero terms for e to the x. Oh, and they're multiplying. Don't they just love that multiplication? Beautiful. So e to the x, 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And then let me check. It asked for the first 3 non-zero terms, and then we're doing a second degree for the multiplication. So I did too many terms. I need to erase this. They could mark me down otherwise. First 3 non-zero terms. No, shushy. So I'm multiplying both of those. I'm going to put e to the x down here. And my f of x I'm going to put across the top. And that's 3/2 x squared. And if I still can't remember what it said, second degree. So I definitely don't need to look any further. Constant term, first degree term, and second degree term. I only need those boxes. So multiply, 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 multiply. Isn't this fun? Multiply, multiply, multiply away. That will end up being 3/2 x squared. When I write this out, I really would say just don't even bother adding numbers together. Unless it's so easy that, yeah, plus x, that's easy. But for x squared, you know, you can do the addition if you like, but you can also just write like -2 plus 3/2 plus 3/2 x squared, and that will give you full credit. However, that's probably pretty quick. That's going to end up being 3 plus x, and if I'm adding correctly, plus x squared. Is that correct? Thank you. So there we go. Then we are moving on to letter C. So h is integrating, and we are going to approximate h of 1 through that integral of our f of x function. So I'm going to go back to, this is our f of x function. I want to grab it and move it somewhere else out of the way. Okay, come on. No, you didn't listen to my lassoing, did you? Oh, my pen decided it didn't want to work anymore. That was the problem. There we go. All right. This is what we are integrating. And it was, can someone tell me it was from what number to x? 0 probably, right? Okay, because it usually will do the center of the polynomial to the x variable. And technically these x's are now t's at the moment. And let's integrate. 3, and you know what? I'm not in the mood. I know that those t's are going to become x's because I'm going to plug in x into the t's, and then I'm going to plug in 0 and subtract, and that won't be anything. So here we go. 3x minus 2x squared over 2 plus 3/2 times t cubed over 3 minus, let's see, that's going to be a 23 over 2 times 6, 12, and then integrate t to the 4th over 4. And now where am I? Sorry. I was integrating the third degree Taylor polynomial, so I have now done that. That is my h of x. I'm now going to plug in 1. So that's pretty straightforward with plugging in 1 once you're there. Now, letter D. It is known that the Maclaurin series for h converges for all real numbers. It also known the individual terms. Oh, yes, they're saying something to you. Alternating sign and decrease in absolute value to 0. What does that remind you of? AST, alternating series test. Then it says to use the alternating series error bound to show that the approximation from h of 1 is at most 0.45. So I'm going to plug a 1 in and 0.45. And actually, I want to go back and check out that error issue that it, oh my gosh, my screen. Okay. To show that the approximation found in part C, okay, it is specifically that whole thing that is the fourth degree polynomial. I was double checking that. When I plug in 1, let me know if I accidentally calculate wrong. Got 23 and then 48. I don't have a calculator, but I'm allowed to leave the answer like that. Now, it is best, you're going to be safest if you state that you recognize this is an alternating series and that the absolute value of the terms decrease to 0, even though they said it. I just, from some of the past exam problems that I've seen, I feel like it is best if you express because this is an alternating series with terms whose absolute value decreased to 0. Because of that, the error is no more than the first omitted term. And I should say the absolute value, but I'm going to just write first omitted term. And now, what is the first omitted term? So now we've got to figure out what the formula actually... Oh. See, we're missing what this next term was going to be able to integrate it to find what the next term is going to be for this function. So I've got to go way back and start off with when I was just creating the f polynomial. What was I supposed to get when n is equal to 4 with the Taylor formula? And I just erased stuff that I wanted to keep. Okay, so now I'm going to check out when n is 4. I am told that the fourth derivative at 0 is 54. So this is the first omitted term that I see from my polynomial representing f. I'm going to integrate it. I'm just going to put integral, constant multiple, and then integrate. I'm starting to factorial too much. And this is my first omitted term of the function, but what was I plugging into x? I was plugging in x equals 1. So I'm going to lasso this, and I'm going to move it over to where I was. So plugging in 1 gives me this value, and that is most likely less than 0.45. And all you need to do is say it's the first omitted term, and the first omitted term happens to be this with a 1 plugged into the x. And you can double check that by calculating it out, but it will be less than that. That's the way they presented it. Is that the whole problem? I'm pretty sure I finished that one. Any questions on it? I'm going to end the video if we're all good.